Hello guys, my name is Vinay Balaji and welcome to another professional prep video. In today's professional prep video, we will be talking about types of discontinuities in calculus. And specifically in this video, we will be talking about types of discontinuities graphically. So, I'll write the title right here. So, types of discontinuities. Alright, that looks pretty good. So there are 4 different types. So I'm just gonna, that was a pretty bad graph. Alright, here you go. I'm just gonna draw 4 graphs of the 4 different types. Right. Alright, cool. So these are types of discontinuities. So there are 4 types of discontinuities that are really important to know. The first type, which is pretty simple, and I'll like to get it out of the way, is oscillating discontinuity. I'll put this in a different color so it doesn't look confusing. Basically, it starts out pretty big, like that, and then it just like, and then it gets bigger, and then basically it gets really condensed. Let me put a different color here. In this area, in the middle area, it gets really condensed. So this is oscillating. Alright, so now let's talk about the next one, which is removable. Basically, say if you have a graph like this, put it in blue, I'll keep it consistent, put it in red. Alright, so say if you have a graph like this. Oh, it's in text. Oh, okay, cool. So say if you have a graph like this, and at this point, there's a hole. A removable discontinuity basically says that if there's a hole here, there's got to be like a point right here where it's filled in. This is really common because sometimes you might be asked to assess the limit of a removable discontinuity, and the limit will be what this point is rather than this point. So example, like this is a quick review, but say if like you're trying to find the limit of f of x when x approaches 6, this would be your answer, and this would be the answer if it was f of 6. Alright, so this is what you call a removable discontinuity. Basically, there is a hole, and slightly above or below it, there will be a filled in circle, which will be your direct solution to your problem. Removable discontinuities, they occur when you simplify a limit to get an answer. The part of the limit that gets canceled out is the hole. So that's typically when you know that's the hole. For removable discontinuity, when the limit gets canceled out. Here, I'll write that down. When limit gets canceled out. Grammarly, alright, cool. Next in line is going to be our infinite discontinuities. Infinite. Alright, cool. Now let's graph an infinite discontinuity. Alright. So in infinite discontinuity, it is basic. They occur when there's a vertical asymptote. And to solve an infinite discontinuity, you set the denominator equal to 0 and just solve to find it. So now I'm going to show you how to do it graphically. So say if we had like a random asymptote right here. Alright, so we have a random infinite discontinuity right here. I meant an asymptote right here, my apologies. And say if we have a graph like this. This would be an infinite discontinuity. Basically, whenever there's a vertical asymptote involved, typically assume that it's an infinite discontinuity. And like I said previously, they can be solved when setting the denominator equal to 0. And finally, let's talk about jump discontinuities. This is really popular in calculus, and they occur in typically piecewise functions. For example, let's say there's something like oops. Oh, I should probably actually write it. Jump. And it's pretty easy to visualize. So say if you have like a function going like this, right? You have a hole here, and then it jumps up, filled in circle, and then continues. The function basically just jumped. Put that in a different color. Oh, that was not a different color, huh? Alright, green. Yeah, alright, cool. So basically the function jumped to here, and then it continues the function. That's how you memorize or understand a jump discontinuity visually. Other than that, those are the types of discontinuities graphically. If you have any questions, please put them in the comments below. Rutvik and I will be happy to answer them for you. In addition, if you have any video suggestions you'd like to see in the future, put them in the comments below as well, and we can make them for you. Other than that, I hope you guys have a really good day, and thanks for listening.